So we are going to start with the organic part, right? So only 2 chapters of 11th standard are left, in which one is what? The organic chemistry, some basic principles and techniques, right? So basically we are learning about the organic, right? So you might have not seen much things in your 10th standard, but here the things are very new for you, right? So try to understand line by line, and if there is any doubt at any point of time, try to ask me, because this 2 chapter will expand in such a way that it will become 5 chapters in your 12th standard. And in 12th standard, one book, that is second part of 12th, is of only organic chemistry. There is no any inorganic, there is no inorganic, there is no physical. So one book is consist of only organic part in class 12th standard. This is interesting also, and this if the basic concepts are cleared, then only you will be able to handle your higher standard questions and even the 12th standard, because in 12th standard the first 5 pages of every chapter is of 11th standard. Getting my point? First 5 pages, whatever has been given in your book, that 5 pages will be of 11th standard only. So if your 11th standard is cleared, then only you will be able to handle your 12th standard. So please keep in mind that you have to make your strong organic here only, right? Okay, so we are going to start. So this is a reflection part. So we are going to learn about what? So we are going to learn about the structures, the functional groups. We are going to learn about the names in first chapter of the organic chemistry, right? So you might have heard about the C2H6, C4H10, C6H12. We will be discussing all about all these things in the chapter in a very brief manner, right? Now, there are some structures that you can see here: C2H4, C2H2, where there will be a triple bond will be there, where there will be a double bond will be there, where single bond will be there. So we will be learning all about carbon in this chapter, right? So organic, from where this organic compound has been, has occurred, that we will be also going to learn in this chapter. So see here, this is ammonium carbonate, right? So there was a scientist whose name was Holler. So Holler was making, he was doing some, some practices in his laboratory. He was a scientist. He was doing some things in laboratory, right? So he was doing what with ammonium carbonate, and he was playing with ammonia, right? But when he was reacting all these things, it was accidentally a new compound has been formed that is known as urea. So urea is an organic compound. Urea is a organic compound that we are giving in our crop, right? That is organic compound, and it was found accidentally by Holler. Is it okay? So who discovered this organic compound first? Holler. So there was a role of Holler, who has found when he was reacting with some inorganic compounds, and he got what? Organic one. And after that, we are having millions of compounds of organic chemistry, right? So that we will be going to discuss. So this was the vital force theory about the what? Holler. So how he has formed the urea from his laboratory, that I have told you. Is it okay? Now come to the next point. So this was the reaction, that is what? Ammonium sulfate and potassium cyanide were reacted, right? So what he has got, final product is what? Urea, that is 2NH2CONS2 that he has got, that is known as what? Urea. This is organic compound, that is what? Urea. Is it okay? So this is theoretical part only. So how and where, from which part we have got the organic compound? This is urea by the Holler synthesis. Holler was reacting these molecules, and he has got what? Urea. It was accident only in the laboratory that he has got urea. Before that, we were not having any organic compound. Is it okay? No. Now, from here we are going to start. See, carbon is having a unique property, that is what? Catenation. What is the meaning of this catenation? Catenation means what? Forming the branch, you can say. Like joining the carbon, you can say. Carbon can join so many carbons and form a long carbon chain, and even it can form a branch chain as well, right? So many compounds of carbon we can see, right? So this is what one straight chain. You can see here branch chain. This is also a branch chain. Linear chain we can having rings of different sizes we can see in the catenation property, right? So ring means what? What is the meaning of this ring? See, if you are drawing like this is what ring you are forming. If a closed compound is forming by this bond line notation, so you will be getting what ring. This is what ring. So ring can be of 6 carbon channel, 6 carbon also. A ring can be also 5 carbon. This can be also a ring. Is it okay? Even this can be also a ring, right? This can be also a ring. These are what ring. This is what straight chain, branch chain. These are what ring. Okay. Now we have to find about the sigma bond and pi bond, right? But we are going to see sigma and pi. What is the meaning of the sigma and pi? Let's suppose if I'm asking carbon, double bond carbon, and here is what CH2 is there. So if we have to find the sigma and pi, try to understand guys, what is the meaning of this sigma and pi? Wherever you are seeing the double bond, it means there is one sigma and one pi is there, right? And if there is nothing, then we have to also satisfy the value of this carbon. Let's suppose if I'm saying this example. Tell me the number of sigma. All single bond will be called as sigma, and in all double bond, one sigma and one pi will be there. So how many sigma are there, Kanishka? 3 plus 2, 5 plus 3, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Total number of sigma is what? 10. Pi, 0. But here you can see here, what is the number of sigma and pi in this compound? See here, pi you can calculate, that is what? 2. That is easy. But what is the number of sigma? See, this carbon will also form a single bond with hydrogen. We don't have to forget these things. This carbon will be not forming any bond with hydrogen. But here, how many bonds can we can see here? 2 with hydrogen, 1 here 3, 1 here 4, and plus 2 hydrogen. So total number of sigma bond is what? 6, and total number of pi bond is what? 2. Is it okay? If I will be going to ask this compound, CH2, CH, CH2, then C, then triple bond CH. Then number of sigma and pi will be what? See, we can open this chain first. How we can open this chain? Carbon, hydrogen, then double bond, then carbon, hydrogen, carbon, hydrogen, carbon, triple bond, carbon, hydrogen, right? So these two are what? Sigma. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total number of sigma is what? 10. And total number of pi is what? 1. And in this 2, so total number of pi is what? 3. Okay, Vishnupriya, no problem. I can understand your problem. I know that the cyclone hits the Chennai very badly, so people are facing problems. I know well, so no need to say anything. You can join directly and start your class. So guys, total number of pi will be what? 2 or 3? What do you say? Yes. Okay, fine. Now, so you can see here we have found this one. We have found this one as well. Total number of total number of sigma 10, total number of pi is 3. Okay. In the third one, you have to practice at home. This you have to practice at home. Now we are going to see the structural formula. What is the meaning of this structural formula? A structural formula means what? See, this one is a structural formula. Carbon, 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 carbon. This is what? A structural formula. After this, we'll be going to see the condensed formula as well. So if it is given in this format, it will be known as what? Structural formula. Is it okay? Fine. Any doubt, any problem? No? So this is what? Structural formula. Now, condensed formula. What is the meaning of this condensed formula? When structural formula is written like this, let's suppose here there is what? Carbon, 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 and hydrogen is there. So I can write like this: CH3, CH2, and CH3. This is what? Condensed formula. Is it okay? So what is the meaning of this condensed formula? Got it? Any problem? Any doubt till here? No? Okay, fine. Now, see here. Ethane can have this condensed formula. This is what? We can write like this, ethane like this. And in condensed formula, we can write like this, CH3, CH3. Right? Ethene, this is what? Ethene. So we can write what? C2H4. This one is what? Condensed formula. Is it okay? Fine, everyone. See, one more example we are having. This is what? CH3, CH2. See, how many CH2 is there? 1, 2, 3, 4, 5, 6 CH2 is there, right? So we can simply write what? CH2, 6, right? And after the COH is there, so we can write COOH. Is it okay? Any doubt till here? No, guys? No. We are going to see about the bond line notation. What is the meaning of this bond line notation? Let's suppose we are having carbon, carbon, carbon. And these are what? Hydrogen, hydrogen, and hydrogen. So we can simply write 1, 2, and 3. Sorry. This will represent your, this is what? Propane. So this is what? This point is 1 carbon. See guys, this is very basic that I am telling you. Teachers are not saying this about this is carbon, but I am also opening these things as well. So these are what? Carbon. Wherever there is, there is mountain like, wherever there is point, you can say that is carbon. And from where it is starting and where it is ending, that will be also a carbon. So this is your carbon, this is your carbon, this is your carbon, right? But let's suppose this structure. Here if I am saying H is there, it means there is no carbon is not there. So only number of carbon is what? 1, 2, and 3 carbon are there. Is it okay? Now, if this carbon is there, if nothing has been given to you, it means there is 3 hydrogen is also there. It is 3 hydrogen here. And with this carbon, 2 hydrogen is there. With this carbon, 2 hydrogen is there. And here there is hydrogen is already, it has been given to you, right? It is okay. Let's suppose another compound if I'm taking. So see, this one is your carbon. So there is 3 hydrogen. This one is carbon. So 2 hydrogen. This one is your carbon. So 2 hydrogen. This one is your carbon. 2 hydrogen. This one is your carbon. 2 hydrogen again. These are what? Hydrogen, 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 hydrogen. Again, this is your carbon. So 3 hydrogen. Is it okay? Any doubt, anyone? No? No. This can be also like this. And here there will be double bond O. Is it okay? So now, see here, this carbon is attached with double bond O. This is what? Ketone group. I will be discussing this group in later on. So this is what? Ketone. So the valency of the carbon is fulfilled already here. So here there will be 3 hydrogen. If nothing has been given, 3 hydrogen with this carbon. Now this carbon is fulfilled. Here there will be 2 hydrogen will be there. 2 hydrogen will be there. 3 hydrogen will be there like this. Is it okay? Now come to the next part. Now your bond line notation, if I will be going to ask you that, see guys, what is there? 1 carbon, 2 carbon, 3 carbon, 4, 5, 6, 7, 8 carbon is there, right? So you can see here 1, 2, 3, 4, 5, 6, 7, 8. And C double bond O, that is C double bond O is there and OH is here. This is what you can see here. How we can draw these things on the bond line notation. These are what? Bond line notation. Is it okay? Any doubt? No? Now see here. If I have to draw the bond line notation for this 1, 2, 3, 4, 5, 6, 7, 8 carbon is there, right? So if 8 carbon is there, so how I can draw the bond line notation for this? So see here like this 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And at third number CS3 is there. So 1, 2, 3. Here I will be drawing what? CS3. Is it okay? Fine. Any problem? Okay. Now, these are what? Cyclic compounds or polygon formula, you can say. Polygon means what? There will be always a closed structure will be there, or cyclic structure will be always having a closed figure. This triangle is also a closed figure. This pentagon is also a closed figure. This hexagon is also a closed figure. But guys, try to understand here. Every corner is having carbon only. So this is what? Carbon. This is what? Carbon. This is what? Carbon. Here also carbon, 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 and carbon. Is it okay? Now, here 2 bond has already been formed. So there will be another 2 bond will be with hydrogen. 2 bond will be with hydrogen. 2 bond with hydrogen. Is it okay? Any doubt, anyone? So I have drawn this 2 also. Now, see, these are these cyclobutene. If there will be double bond will be there, then will be a cyclobutene will be there. This is what? 1, 2, 3, 4, 5. 5 pentane is there, right? 6 is there, hexane. And 7 will be there, then 6 will be there, and then again hex. What is the functional group that you might be not knowing right now? So no worries about that. We'll be discussing later on. Now another method of representing the carbon and other things are what? That is 3-dimensional, or you can say that we can, this carbon is having A, B, C, D, you can see here. If dashed line is there, right? Dashed wedge, we can say dashed line means what? Away from the observer. And the solid line will be representing what? Bond towards the observer. This dashed line will be representing what? Away from the observer. Away from the observer. Okay. And this strong line or strong bond will be representing what? That is bonds towards the observer. Towards the observer. Okay, any doubt? No? Now, come to the next point. See here. So this we have seen, bond line and dash line. Now see here, we have seen what? Structural formula. This one is your structural formula, right? Condensed formula, we have seen this condensed formula. Actually, we are revising this structure, then condensed. Now, this is what? Bond line is structural formula. This is what? Bond line. And this is what? 3-dimensional formula that we have seen. Is it okay? No. Now we are going to discuss about the classification of organic compounds, right? Just give me a moment, I'm coming. Okay, everyone. So we were classification of organic compounds, right? So one is what open chain or acyclic compound. Am I clearly audible to all of you? Just please turn on your camera. So one is what open chain, or you can say that what is acyclic compound. Open chain. Open chain is what? This is open chain, right? This is what open chain or acyclic. Acyclic means what? They will be not forming a ring. This is what ring. This is what cyclic. This is what open chain acyclic compound. Here closed chain or cyclic or ring compounds are what? These are ring compounds. These are what? Ring compounds or closed chain or cyclic you can say. Acyclic is what? This is a long form of chain will be called as acyclic or aliphatic. It is what? Aliphatic. Aliphatic. Is it okay guys? Any doubt till here? So you can write this word aliphatic because it is coming again and again in your organic chemistry. So if there will be a single bond, you can say single or double bond will be there, but you can say that open chain is there. It means what? This is aliphatic, right? Phatic means what? That is this is actually the word has been come from the Greek word, right? Aliphatic. Now here you can see here aliphatos meaning fats. Aliphatos means what? Fats. So actually it has come from the animal or vegetables fats. So this is known as what? Aliphatic. So you can see there, these are what? The aliphatic compounds. You can see here the open chains are there. So either the double bond or triple bond or single bond will be there. This will be called as what? Aliphatic, open chain or acyclic compound. This is what? Open chain or acyclic compound, or what you can say this is what? The aliphatic compounds, right? So there will be a closed chain or ring chain, ring compound, or you can say what? Cyclic compound that we have seen, that is a benzene is a best example for all this what? That is benzene. Benzene is what you can see here. This is a structure. This is what? Closed chain. This is what? Benzene. So closed chain. You can say what? First one is closed. Second we can say what? Ring. Third we can say what? Cyclic. These are what? Cyclic. But these are what? Aliphatic. Aliphatic, 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 or acyclic. You can say what? Acyclic or aliphatic. Is it okay? No. Next point. So see here. See here, closed chain or cyclic or ring compounds. This compound contains chain or rings of atoms in their molecules. This compound may be carbocyclic containing ring. See here, this is what? The ring. See guys, this is what? Nothing, this is a ring. Right? So ring. So now see here, this is what? Cyclopentane. This is also a ring. This is also a ring. This is also a ring, right? Now, this compound contains a ring of 3 or more carbon atom in them. They resemble the aliphatic compounds in many of their properties. For example, you can see that we will be seeing, right? So here we have seen what? Open chain or acyclic, right? Open chain or acyclic. Got my point? See here, open chain or acyclic. Acyclic we have seen, right? By mistake, if I have written anywhere alicyclic, then please remove that. Although I haven't written anywhere alicyclic, acyclic will be there, right? So there is no alicyclic. Alicyclic is what? Aliphatic is there and acyclic is there. So let's suppose if I have told you anything about the alicyclic, so please remove that. So we are discussing about what? Acyclic, and if the single bond will be there or double bond will be there or long form will chain will be there, it will be what? Acyclic, or you can say that what? That is what? Aliphatic, right? Now, alicyclic is what? See, alicyclic compound. This compound contains ring of 3 or more than carbon atoms in them. So 3 or more than ring will be there. It will be called as what? Alicyclic compound. Is it okay? So these are what? Alicyclic compounds, or you can say what? Ring compounds, or it is what? Closed chain compound. You can say that is what? Closed chain. Now we are going to see what the aromatic compounds. What are aromatic compounds? See guys, aromatic. This is very important terminology for your organic chemistry, aromatic. Although aromatic word we will be describing later on, but for here, please try to understand what. If double bond is coming at alternate position, if double bond is coming at alternate position, see, let's suppose here is one bond, here is one bond, and here is one double bond. If double bond is coming at alternate position in benzene ring, because benzene ring is the combination of what? 6 single bonded carbon and 3 double bond will be there, right? So double bond is coming at alternate position. If a double bond is coming at alternate position, it means what? This is an aromatic compound. So benzene is an example of aromatic compound, but every aromatic compound will not be benzene. Getting my point? So what you have configured that benzene is always an aromatic compound, but always aromatic compound should be a benzene. That is not true, because aromaticity can be found in 6-membered ring, 7-membered ring, 8-membered ring, any ring, right? That we have to see. So, and benzene can be also written in so many ways. How we can write? This is also benzene, right? We can also draw like this. This is also benzene, right? We can also draw like this. Alternate position double bond will be there. We have to keep the funda is what alternate position double bond will be there. Here we can draw what? Hydrogen, 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 hydrogen will be there, right? Here will be what? Hydrogen will be there. So C6H6 is the formula for this benzene. Is it okay? Fine. Now see here. Classification of organic compounds. See here. This is also an aromatic compound. See guys, alternate position means what? You can see here. Double, single, double, single, double, single. There is what? At alternate position, double bond is coming. So if double bond is coming at alternate position, it means what? Aromatic compound. Is it okay? Any doubt? If double bond is coming at alternate position, it means what? This is an aromatic compound. But now you may ask me, sir, here double, single, single, single. So how this is aromatic compound? Guys, you have to check it very carefully. Double, single, then double, then 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 single, then double. In this ring also, if you will be going to see double, single, 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 double. So you may found what? The alternate carbon double bond will be there. So these all are what? These all are what? Aromatic compounds. Aromatic compound, right? If I will be going to ask what is this aromatic compound? So for now you have to say what? So any ring, if there is alternate double bond is coming, right? If in any ring double bond is coming, in any benzene ring, if double bond is coming alternate position, then it will be called as aromatic compound. Right? No. See here. This is also a what? Aromatic compound. This is known as what? Biphenyl diphenyl. Biphenyl or diphenyl. Triple bond. 3 double bond is there, and here 3 double bond is there, right? And they are joined with what? Hydrogen has been removed from here, hydrogen has been removed from here, and it has been joined. So this is also a what? Aromatic compound. Is it okay? So this is what? Polycyclic aromatic compound. Polycyclic aromatic compound. This is triphenyl. See guys, if let's suppose I will be teaching you in the nomenclature part. The carbon is there. This is known as what? Hydrogen, hydrogen, hydrogen. If one hydrogen will be removed, so it will be called as what? Although it is methane, but if hydrogen will be removed, then it will be called as what? Methyl. No. Next point. See here, in addition to these are some compounds which show aromaticity but do not contain any benzene ring. So these are what? These are aromatic compound. These are aromatic compound, but they are not benzene. They are not benzene. So you may write these things that what? These are aromatic compound, but they are not benzene. So I have told you one thing, that every benzene is an aromatic compound. But every aromatic compound must not be benzene. Is it okay? So you can see the examples from here that they are, although they are aromatic, but they are not benzene. Is it okay? No. So tropane, tropopolene, and azulene. You can see these are the examples of what? That is aromatic compound. Now we are going to see about the heterocyclic compound. Hetero. What is the meaning of this hetero? Hetero means something different, right? Hetero means what? Different. So many students have joined today. Please turn on your camera. Karthik, Pranav, Mukeshwaran, Raghav. I know you might be facing some issues with the camera today, as the rain and cyclone has hit your area very badly. I just wanted to know from your side that how you all are, guys. Everyone is good at your home, and what about your loved ones and your family members? Is everyone is good? Are you still facing problems with electricity cut, power supply, water scarcity, or water logging? Are you still facing these problems in your area? Guys, please tell me. Vishnu Priya? For whom? Sometimes, sir. Okay. Okay. I hope everyone is good at your home. Vishnu Priya, DRT, Pranav, Ashwin Karthik, Mukeshwaran, Kaniska, everyone is good at your home, right? Okay, thank you. Okay, now let's continue. Okay, Vishnu Priya. Hope everything will be on track very soon. Now, heterocyclic means what? See, guys, if carbon, these are what? Carbon is there, right? So if at every point if carbon is there, so it is homocyclic, right? But apart from this, anything will be there. If anything will be there at the ring, so it will be called as what? A heterocyclic ring or a heterocyclic compound. So here it might be, let's suppose O is there, so it is what? Heterocyclic. If let's suppose here N is there, in this ring, what is there? N is there, it is what? Heterocyclic. Here again O is there, it is what? Heterocyclic. Here S is there, so heterocyclic. N is there. So in the ring, everything should be carbon. At every corner, if it is carbon, then it will be called as homocyclic. And if any ring, anything will be apart from this carbon, so it will be called as what? Heterocyclic. Is it okay? Anyone is having any doubt? This is something else can be there. So if in any ring, apart from carbon and hydrogen, any atoms is coming like oxygen, nitrogen, sulfur, or chlorine, anything is coming in the carbon ring, so it will be called as what? Heteroatoms, or the compound will be called as what? Heterocyclic compound. Is it okay? Everyone, any doubt till here? No? Okay, fine. Now we are going to see about the functional group, right? The very first functional group that we are going to see about what? Alkene. If their double bond is there, so it is what? Alkene, right? So many functional groups are there. You might have learned in your earlier classes also. Aldehyde, alcohol, and that is ketone, carboxylic acid. You might have seen in your earlier classes as well. But now again we are going to learn this functional group, and it is a variety of functional group I will be bringing for you guys to understand that how we can do the nomenclature from that functional group. Is it okay? Any doubt in here? No? No. See here. So alcohol is one functional group. Aldehyde. So alcohol formula is what? OH. Aldehyde. This is what? C double bond O single bond H. Carboxylic acid, C double bond O single bond OH is the formula for this functional group, right? No. Alkenes, so C double bond C is what? Alkene. Alkynes, C triple bond C, alkyne. Arenes is what? That is benzene. You can say benzene ring is the example of arene, right? These are the examples of what? Arenes. Is it okay? Any doubt till here? No. Aldehyde, alcohol, ethers. Now, new compound that you are going to see, you might have not seen in your 10th standard. This is what? Ether. COC, or we can say ROR is what? Ether. Amines, that is what? CNS2. If C or RNS2, we can say RNS2 will be there. It is what? Amines. Or CNS2 is what? Amines only, right? Thiols, that is what? C. SH is there, so it is what? Thiols. These are the functional groups that we have to learn. Aldehyde ketone carboxylic acid we have seen, guys, right? This is what? Ester. Ester is one new compound. That is what? That we will be going to see. C double bond O and OR. So R C C. We can see C double bond O, C single bond OR. This is what? Ester. This is nothing. This is what? Ester. Is it okay? Now, acid halides. Acid halides means what? C double bond O and X will be there, and this X is what? Chlorine, bromine, iodine. This is what? Acid halides. Amides, or you can say acid amides. That is what? C double bond O and NS2 will be there, right? NS2 group will be there, and here carbon will be there. So this is what? Amides. Nitriles, there will be what? C triple bond N will be there, and here carbon is attached with this, so it will be what? Nitriles. Is it okay? Now, we are going to see about the homologous series. What is the meaning of this homologous series? See, guys, let's suppose we are having what? Ethane, CH3, CH3, right? Now, propane, that will be what? C, C, C. Number of carbon and hydrogen is what? C2H6. Here the number of carbon is what? C3, and H is what? 3 plus 2, 5 plus 3, 8. So homologous series is what? There will be a difference of CH2 group. So if you are going to subtract, so what you will be going to get here? C2, CH2. So if there will be a difference of CH2 molecules, then that series will be known as what? Homologous series. Is it okay? No. CH3OH here. There will be a difference of only CH2. In this compound, if you will be going to see, that is what? C2H5 is there, C2H5OH minus CH3OH. So here C and C will be minus, so C has been minus, right? So what you will be going to get? C2H5 is there, so what you will be going to get here? CH2 again. Here also you will be getting what? CH2. So these all are what? Homologous series, right? Now, all the members of the series can be represented by a general formula. For example, members of the alcohol family will be represented as what? CN H2N plus 1 and OH. The general formula for the homologous series of the alcohol, right? Is it okay? Any doubt till here? No. Different members in a family have common functional group. That example is what? OH group and the functional group, right? So we have seen about the functional group. Now we are going to do what? IUPAC nomenclature. We are going to do what? Nomenclature part, right? See. First of all, you have to learn what? See, guys. We are going to see the nomenclature part. So you have to see what? Word root and chain length. Try to understand from here. So word root is what? If one carbon is there, so we'll be calling what? Meth. If two carbon will be there, then it will be what? Eth. 3 carbon, prop. 4 carbon, mute. 5 carbon, pent. 6 carbon, hex. 7 carbon, hep. 8 carbon, oct. 9 carbon, non. 10 carbon, dec, right? 11 carbon, undec. See here. Undec, right? 12 carbon will be there, then dodec. 20 carbon will be there, then icosane. If 30 carbon will be there, then tricotane. So these are the what word root and their what number of carbon. Is it okay? So we have discussed these things, guys. Any doubt to anyone, then please let me know. Any doubt to anyone? No? No. Now we have to also see the functional groups, right? What are the functional groups? So we have to first see about what alcohol. This is what alcohol, OH, aldehyde, CHO, ketone, C11O, carboxylic acid, COH, ester, COOR, we have seen earlier, acid chloride, COCl, acid amide, CONS2, nitriles, C triple bond, and amines, that is what NH2. So these are the what functional groups, and their suffix are what OL, AL, ONE, oic acid, alkyloid, oil chloride, that is acid chloride. For acid amides, it is what amide. For nitriles, it is what nitrile. For amines, it is what amine. So we will be using this prefix in our nomenclature part. No. For fluoro, F, that is what fluorine. The prefix will be used. That is what fluoro. For chlorine, chloro will be used. For bromine, bromo will be used. For ido will be used. NO2, nitro will be used as a prefix. NS2, amino will be used as a prefix. NO, nitroso, and N double bond and diazo, and OCS3, methoxy, that is what COC will be becoming methoxy. OC2H5, that is what COC2H5, that is what we will be using. Here there will be long form carbon chain will be there, so it will be what ethoxy. So for ether we will be using methoxy, right? For OH we will be using what prefix hydroxo. Now see here. Here we are having a compound. Name what we have to name this compound. First, tell me. I'm going to make you write what is the name of this compound. If one, see guys, if carbon single bond is present, between carbon and carbon, so we'll be saying this A and E. If double bond is present between carbon, is ene. If triple bond is present between carbon and carbon, so we'll be calling this what ine, right? We are knowing the word roots, we are knowing these things, now we can name the compound, right? So first of all, tell me what will be the name of this compound, guys. Please, I want the answer from your side. What will be the name for this compound? Methane? Very good answer. No. Then, what will be the name for this compound? See, 3 carbon is there, so prop, and single bond is between carbon and carbon, so propane, right? Is it okay? No doubt? Okay. Now, what we'll see? We are going to see about this compound first. What will be the name for this compound? We have seen the functional group. See guys, we have to learn the priority order of the functional group. We are having 2 functional groups, OH and Cl also, right? But Cl, you see here, we have seen that are what prefix. So the main rule is saying what? What is the rule for this nomenclature? We have to do what? First of all, what we are going to do? Prefix. So first count the number of carbon chain. So carbon chain we will be counting from where? Where the main functional group is attached. So the main functional group is what? OH, and Cl is what? It is coming in the priority list later on. So we will be counting our carbon from here. So 1, 2, 3, 4. Is it okay? Fine, everyone. So now, at third position, chlorine is there. So we'll be saying what? 3 chloro, and then bute. 4 carbon is there. So we'll be saying what? Bute. And single bond is there. So A and E plus ol for alcohol, ol. So 3 chloro, butane, 1 ol. Is that okay? No. So what is the golden root for the nomenclature? First of all, you have to write prefix, then word root, then primary suffix, then secondary suffix. Is it okay? This is a golden rule for doing the nomenclature. Now, see here. We are going to discuss about the degree of carbon. See here. What is the degree of carbon? Right heading degree of carbon. See, a carbon. See first here. This carbon is attached by how many carbon? One carbon. This. So that because others are what? Hydrogen. These are what? Hydrogen. So this carbon is attached by one carbon only with this side. So the degree of this carbon is what? 1 degree. But what about this carbon? This carbon is attached by two carbons. See here. This carbon and this carbon. So the degree of this carbon is what? 2 degree. What about this carbon? The degree of this carbon is what? Again 1 degree. Because this is attached by this carbon only. The degree of this carbon is what? 1 degree. Is it okay? Everyone, please tell me if there is any doubt. So we have seen about the degree of carbon. Any doubt? No? No. For do this question. See CH3, CH2, then CCH3, CH3, CH, CH3, then again CH3. Can you please tell me what is the degree of the carbon for this? Where I am doing a star, tell me the degree of carbon. Guys, try to do from your side. See, the degree for this carbon is what? 4 degree. And degree for this carbon is what? 1 degree. So those who have given the answer for this question, this is correct one. Right? We are going to see about the alkyl radical. What is this alkyl radical, guys? See, carbon is there. So carbon must have what? 4 hydrogen. Where the valency is what? 4 tetravalent compound. So if I am removing this hydrogen, right? So it will be called as what? Alkyl radical. So this is what? One carbon is there. So one carbon name is what? Meth. So we will be calling what? If CS3 is there, it will be called as what? Methyl. Let's suppose we are having 2 carbon. And we are removing what? 1 hydrogen from here. Let's put in from anywhere. We are removing this hydrogen. So we are left with only 5 hydrogen. So this is what? Ethyl. Next one is what? Let's suppose we are having what? 3 carbon. And we are removing this hydrogen from here. So this is what? Propyl. Is it okay? Fine. Now, see here. So this is what? Methyl, ethyl, propyl, butyl, pentyl, decyl. If 10 carbon will be there, so it will be what? Decyl. So one hydrogen less than the number of carbon, than the number of hydrogen required in the carbon chain will be called as what? Alkyl group. Is it okay? So based on the number of carbon, it will be methyl, ethyl, propyl, butyl, pentyl, decyl. Now, see here. Now, see here, the name of these compounds are what? HOCl unstable formyl chloride. We will be discussing this later on. Okay guys, do one thing. Have a break of 5 to 7 minutes, then we'll be back. Right? So guys, please try to understand from here. Are you there, everyone? Okay. See. Now we are going to see alkyl radicals. See here, alkane, and we will be removing this E from alkane, right? Y will be there for halide, right? So for my chloride, common name will be there, but for IUPAC it will be what? Methane oil chloride, right? For C here, CH3COCl is there, right? So it will be what? Ethanol chloride. Or we have, so if CH3C and OCl is there, so it is what? Acetyl chloride. Now in IUPAC we will be calling what? Ethanol chloride. CH3, CH2, COCl is there. So three carbon is there. So it is what? Proponyl chloride. 4 will be there, then butanol chloride will be there. Is it okay? No. Acid anhydride. If there be acid anhydride or any functional group will be there, so how we will be going to name this functional group? That we are going to see. Acid anhydride, right? So CH3, C double bond O, single bond O, and then COCH3 will be there, right? So it will be called as what? Ethanic anhydride. See how it will be. C double bond O, then C double bond O, then R. So we can call this what? RCO2, then O. So simply we can write C double bond O, then single bond O, then C double bond O. Is it okay? Any problem till here? Any doubt? So it will be what? Ethanoic anhydride, propanoic anhydride, then again COC2H5 is there. It will be what? Ethanoic propanoic anhydride. So that we have seen, right? That's the formula for this ester. RCOOR. R, C double bond O, single bond O, and R dash. Is it okay? Or we simply we call this what? C double bond O, OR. If this will be the case, then it will be what? Then ester. Secondary suffix is what? OA. Now we are going to see the nomenclature for this. What will be the name for this? See here, one R is there, so it is what? Methyl methanoate. Suffix is what? OATE, OAT, right? If 2 carbon is there, so it will be what? Ethyl ethanoate. Now here it is what? CCH3 and COOCH3 is there. It will be what? Methyl acetate or methyl ethanoate. This part will be what? Ethanoate, and this part is what? Methyl. Here it is what? Ethyl ethanoate, because there are 2 carbon here and 2 carbon this side. So it is what? Ethyl ethanoate. Is it okay? So methyl methanoate, ethyl ethanoate, methyl ethanoate. See guys, what will be happening here? More will be the carbon, it will be going into the OH part, and lesser will be the carbon that will be going into the IL part. Now we are going to see about the acid amides. Acid amide means what? It will be like the C double bond O, and N will be there, right? See here, what we are going to see here, CONH2 is there, CO and NH2 is there, right? And here CH2 is there. So what will be calling this? Ethanamide. Here it will be called as what? Propanamide. So 3 carbon is there, 1, 2, 3 carbon is there. So it will be what? Propanamide. This is what? Ethanamide. Now see here. Now we are going to see about the amines, right? We are going to see about what? Amines. So N, CS3, and what will be there? NS2 is there, right? So it will be called as what? Amines. Here one carbon is there, so it is what? Methanamine. Methanamine. Here two carbon is there, so it is what? Ethanamine. Again here, 3 carbon and NS2 is group is there, so it is what? Propanamine. Propanamine. Is it okay, everyone? So NS2 group basically will be called as what? Amine. Now, we are going to see about what? Alkyl cyanide or alkane nitriles. So C triple bond N will be there, and here R will be there, so it will be called as what? Alkyl nitrite. It is what? Nitriles. Yeah, alkane nitriles, or we can say cyanides, right? So what will be the name for this? See here, CS3, right? And C, we can write like this: C triple bond N. So this carbon is attached by one carbon, right? So it will be what? Ethane nitrile. Is it okay? Here, propane nitrile. Propane nitrile. It means what? It will be like this. So this carbon is attached by another carbon, so it will be what? Propane nitrile. Is it okay? If you have to write butane nitrile, so how will you be writing butane nitrile? First of all, draw 4 carbon, and with the 4th carbon you have to draw N, and these 4 carbon will be what? Bute. So butane nitrile. Is it okay? Propane nitrile, butane nitrile, ethane nitrile. Is there any problem, guys, in these? No? No. See here.
Hello, Vinayak sir.
Yes.
Yeah. Sir, your camera is off.
No, my camera is not.
So just refresh from your side, because from my side is looking your camera is off.
Is it visible now? Am I visible, guys? Am I visible to you, all of you? Please write in the chat section, guys. Am I visible to all of you? No? Still no?
Yes, now visible, sir.
But students are saying that I am not visible.
Hello, students. Sir is visible to you. Hello. Hello.
Yes, everybody is typing that no.
So just refresh from your side. Pranav, Vishnupriya, Arti. Just refresh once.
Okay, guys. So now see here. Now we are having what? Isocyanide or isonitriles or carbylamines. So see here. How we will be writing this? See, actually, what happens here? Nitrogen is only forming, three bonds. Is it okay? But here you are saying that nitrogen is forming what? 4 bonds. So in that bond will be coordinate bond. Is it okay? One bond will be what? Coordinate bond. Is it okay, guys? So now, in the common system, their names are derived from the adding suffix carbylamine or isocyanide to the name of the alkyl group. See here. So here, what will be saying this? Common name is what? Methyl isocyanide or methyl carbylamine or methyl isonitrile. Here 2 carbon is there, so ethyl isocyanide or ethyl carbylamine or ethyl isonitrile. Now, nitroalkane, see here, what will be happening in this case? and O2 group is there. R and O2 group is there. So again see here in this case what will be happening? R, right? One bond. Nitrogen double bond with this oxygen, and nitrogen is forming 4 bonds, so it is not possible. So it will be happening what? Here there will be coordinate bond between nitrogen and oxygen will be there. Is it okay? So the word that we'll be using for this is what? Nitro. Okay. Now see the name for this. So CH3NO2 is there. So it will, the IUPAC name will be what? Nitropropane. Nitro, see, nitropane. It is what? How many carbons are there? Based on the number of carbon, we will be saying the name. See here. What will be the name for this? This is nitropropane. This is, see here. This one, 3 carbon is there, so nitropropane. Again, this 3 carbon, nitropropane. 2 carbon, nitroethane. 4 carbon, nitrobutane. Here 4 carbon, nitrobutane. Is it okay? So if NO2 group is there, then we will be saying what? Nitro. And CH3 is what? CH3 is what? That is 1 carbon, that is what? Nitromethane. 2 carbon, then nitroethane. 3 carbon, then nitropropane. 4 carbon, then nitrobutane. Okay. Now we are going to name some compounds. See guys. Although we have seen so many things, now we are going to do the nomenclature part. See here. So basic things we have seen. Now tell me the name for these compound first. See here. First compound. Now tell me guys, what will be the name for this compound? Please write your answer in your chat, in the chat box. So this is what? Butane. This is correct. Now, second one, who will be telling me the name of this compound? See guys, how we have to do the nomenclature part? See here. See the substituent. This is what? Substituent here. What is what? Substituent. We have to see what? The substituent is coming from which side earlier. Like let's suppose if I am counting from here, this is 1 carbon. 1, 2, 3, 4. So here we are getting what? At second number substituent is there. But if I am going from right to left, substituent will be coming at third number. So our counting should be from left to right. That second position CH3 is there. So we will be calling the CH3 is what? Methyl. So 2-methyl butane. 2-methyl butane. Very good answer that we are seeing. Now, how will we be counting this? We should count from left to right or right to left. Who will be telling me? Left to right or right to left? See guys, from where you will be getting the least locant, that is least number of the what? The that is substituent functional group. That from that side we have to start our counting. So we should start our counting from right to left. Why right to left? Because at the first carbon only we are getting what? The Cl group. At second carbon also we are getting Br group. These are what? Substituents. So third, fourth, fifth, right? The name should be what? 1 chloro. So sorry, 2 bromo, 1 chloro, 2 bromo, 1 chloro, pentane. See guys, single bond is between carbon and carbon, so pentane. If there will be any double bond will be there, so we have to specify the position of double bond and we will be writing what? E. Now, what about this question number 4? What will be the name for this? See, here there are two functional groups are there. One is what? Alcohol. For alcohol, and this is what? This part is what? This is carboxylic acid. This is what? Carboxylic acid. Carboxylic acid is coming at, top position of the priority list. So this will see, if two functional groups are coming at the in one carbon chain, so we have to prioritize that which carbon is having, which functional group is coming in the priority list first. That will be act as a suffix, and rest of the functional group will be act as a prefix. For OH, alcohol, you might have heard earlier also, the that is what? Hydroxy. And we'll be counting from where? And we should start our counting from left to right or right to left. See guys, if you will be going from left to right, so at second position you will be getting what? OH. But if you will be coming from right to left, so at first position you will be having what? The functional group. So we should start our counting from right to left. So the name will be what? The name for this compound will be what? See, 4-hydroxy. Yes, good answer. Because one carbon, second carbon, third carbon, fourth carbon, fifth carbon. So 4-hydroxy, and then pentane, 1-oic acid. 1-oic acid. Is it okay, guys? 4-hydroxy, pentane oic acid, pentanoic acid or pentane 1-oic acid. You can write like this. Is it okay? Now, some more questions. Yes, guys. Try from 6th number. Tell me what is the answer for 6th number. Who will be telling me the answer for this question? Question number 6. So those who have given 2-ethyl butane, all are wrong. See here. We can open this chain. I have given this question, I know that you will be giving the same answer. See, we can open this chain. C, 3 carbon, and again here C, and again in the top we can write C. We can write like this. And it will be what? CS3. So now tell me, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. So, and this will be your what? Substituent. So 3-methyl pentane. This is the right name for this compound. Is it okay, guys? Now, what about the 7th number question? What is the name for this? So see, 1, 2, 3, 4, 5, 6. It is simply what? Hexane. Is it okay? What about question number 8? 1, 2, 3, 4, 5, 6, 7. It is what? Heptane. Heptane. See guys, what will be the answer for this question? Question number 9. Try guys, please tell me what is the answer for this question. See, carbon number 1, carbon number 2, carbon number 3, carbon number 4. So it is what? Nothing, cyclobutane. Right? This is what? Carbon number 1, 2, 3, 4, 5. So cyclopentane. Right? What about question number 11? See here. So from where double bond is there, we have to start our counting from that side only. So 1, 2, 3, 4, 5. So then what we can say for this? Cyclopent 1-ene. Right? Or cyclopentene we can say, right? What about this compound? Guys, please tell me what is this? See, actually this is what? Benzene, right? And benzene, see, in this benzene, what happens in benzene? First of all, do this question, then we'll be doing this. See guys, Raghav, not 3-chloro, not 3-chloro. See, wherever chlorine is there, you can start from there counting. So 1-chloro hexane. One, two, three, four, five, 6. So 1-chlorohexane. This is not the place that you can start that counting from here only. Wherever the substituent will be there, wherever the functional group will be there, you can start your counting from there. One more question, first of all. this one. See guys, how you should start your counting. Bromo 1, as this is methyl 1, so 2, this is what chlorine, that is what 3, but we have to also take care of the alphabetical order. When we will be counting, when we will be writing, we have to take care of the alphabetical order, right? So what will the name for this? 1 bromo, 3 chloro, 2 methyl, cyclohexane, 1 bromo, 2 chloro, sorry, 3 chloro. In alphabetical order, we learn B, C, then M. Is it okay? Next, one more. Do these 3 questions, guys. See, this is what keto group. Name of this functional group is what? Ketone. This is what chlorine. First do this. So we will be calling this what? 2 chloro. 2 chloro, propane. This is what? 1, 2, 3, 1, 2, 3, 4. So 3 methyl and 1, 2, 3, 4, 5, 6, 7, 8. So we will be calling what? 5 ethyl, 3 methyl octane, right? Name for this will be what? 1, 2, 3, 4. 4 carbon is there, right? So bute 2, butane, and the double bond is there, right? Butanone is there, so bute 2-one. Or we can say what? Butanone. Now do one thing, start your class assessment, guys. Start your class assessment first. Is it visible to all of you? Then start your class assessment and we will be discussing that. Done.